Okay, let's do the next example. Okay, employee's age. The next table summarizes the age distribution of a company's employees. So let's look at that. So the chart shows this age, of course, number of years, and the probability. So 20 to 34, 20 to 49, 20 to 64. I feel a little strange because each time I see the same age from 20. So what does that mean? That means this group includes the previous group. This group includes the previous group. So what I see over here is, and those probabilities add up to 0 at the end. So that means this is a kind of a cumulative, okay? So in order to sort out this age group, so what do we need to do? We are going to do it. This is a probability. So this time they are all disjoint groups. So first group is anyhow the youngest group, 0.15. And the next group includes the youngest group over here. So you remove this age group, that means you remove this probability, so that gives you 0.55. Agree? And for this group includes this group, so therefore 0.90, you remove 0.7, that makes 0.2. And likewise over here, this is the oldest group, and you are going to remove this part, therefore it leaves 0.1. Okay, so now we can answer over here. Well, we already answered. Yes, so this part is cumulative. This part is all disjoint. In other words, just one way or another, 20 to 34, and this group must be, oh okay, I need to write over here. I'm sorry. So this means this is for 20 to 34 in terms of age. This is going to be after that, so 35 to 49. And after that, so this is 50 to 64. And this is from 65 to 79. Make sense? Okay. So when you do homework, I want you to look at the table carefully if that shows those probabilities, cumulative ones or not. Okay. Example 9. Venn diagram is given. Yes, this time, in other words, all those parts of this Venn diagram, the probabilities, associated probabilities are given. Can you sort out and answer? Okay? So this time, you have two events, E and F, and of course outside is a sample space. Okay? Therefore, the whole probability is 1.00 exactly. And this portion, 0.05, 0.4, and 0.25, and 0.3. So how do we understand this? Well, each portion has its own piece. Therefore, there is all disjoint, again, like a jigsaw puzzles. Okay? So that gives you 0.3, 0.7, 1, exactly. Okay. From this, let's calculate the probability of event E occurs. Event E means the entire circle E. Okay, so it has two pieces, so 0.05 plus 0.4, that gives you 0.45. B, probability that exactly one over E or F occurs. Probability that exactly one of E or F occurs. So what does that mean? Which portion indicates that? Look at this point 4. This point 4 means event E occurs and at the same time event F occurs. That's why it's in the overlap. Okay? So that means exactly one portion over here, 0.05, and plus here 0.25. That gives you 0.30. Okay. The next one, determine the probability that, okay, this is an interesting one. F occurs but E does not occur. Yes. F occurs but E does not occur. So can you describe this one as this Venn diagram? F occurs, so that means probability that inside of F, but E does not occur, so but outside of F. You can visually, you can switch to this statement like this. So where is that? Inside of F. So there are two portions over here. So 1, 2, 3, 4 again, but outside of F. Therefore, this 2 cannot be the case, correct? So exactly that's one portion over here, 1. So that gives you 0.05. Okay? Part D. Determine the probability that F does not occur. F doesn't occur. Alright, so does not occur, therefore in terms of Venn diagram, it has to be what? Outside of F. So probability that outside of F. So you have a two choice over here when you arrive at this. So that means you can use 1 minus the entire possibility over here. Okay, sample space has probability of 1 minus inside of F. Make sense? It's a complementary case. Okay, so that is 1 minus inside of F, that is 0.65, right? So 0.65, that gives you 0.35. That's how you understand this one. On the other hand, let's just go piece by piece. So outside of F, well, what's out there? What's out there is this portion, okay? What's outside this F is this portion and this portion. So that gives you 0.05 plus 0.3. That makes 0.35. So either way, you get the same answer of 0.35. Does it make sense? Okay? So we can be flexible how you understand how to look at things. Alright. This time, it's not printed over here, but let me double check. Probability that this time E occurs but F does not occur. Doesn't. Where is that? E occurs but F does not. Oops. F occurs but E does not. Oh. Gosh, I made a mistake over here. F occurs, but E does not occur. So it has to be this portion inside of E does not occur. Oh, so I have to switch. F occurs inside of F, but outside of E. I'm very sorry, okay? I always think about E first, so that's how I made a mistake over here. So outside of E. Therefore, it has to be 0.25. I'm very sorry about that. Okay, here is the opposite case. Probably this one you already know the answer then, okay? E occurs but F does not occur, so it's going to be inside of E but outside of F. Therefore, this answer is 0.05. I'm so glad that I asked. Okay, the last question over here is probability that neither E nor F occurs. Where is that? So that means outside of E and F. So outside of E or F. So that outside E or F, that gives you 0.3. So now you think of those before, when you took the exam, okay? We talked about that, okay? Those club members went to annual flower show and home and patio show stuff. Some people went to two shows, some people went only one show, some people didn't go any shows, okay? So that is like as we sort out whether these are the number of elements over here or these are the probabilities associated with each piece, we are going to handle that way. Okay, so this Venn diagram is very important and very intuitive, and just so it is a wonderful tool to use to study this kind of stuff. Okay. Oh, another thing is when you do homework, my math lab may give you just expression. So rather than this like a word stuff, so let's write this one as well. F occurs, but E does not occur. So that means, and E doesn't occur, so it has to be E prime. And it has to be what? Intersection, because they occur at the same time. They do it that way. Okay? So this time E occurs, but the F doesn't. So this is the same as probability that E intersection F prime this time. And neither E nor F occurs. So that means this one is probability. Oh, that's not good. This means probability that E this way, okay, or probability that E prime intersection F prime. Yes, when you do today's homework, you are going to see that it is very beneficial if you recall the Venn diagram. I'm sorry, not Venn diagram, De Morgan's law. So let me refresh you about that. Okay? De Morgan's, that is E union F and the prime. This is the same as E prime intersection F prime. You just distribute this prime to each one and then take the opposite. So likewise, E intersection F prime is E prime union F prime. Okay, they are equal, but one is more kind of easier to use or easier to visualize. This side is easier. This side is easier to use because the right side is what you have to deal with the two primes. You know what I mean? But over here, so take a union and go outside. But this time, what? Take an intersection and go outside. That's the difference. And so this part is, I'm sure that part is easier. Okay, so when you do today's homework, yes, the last example, example 9, we just did, yes, they are going to ask a lot of that. Okay, and all different problems over here, yes, they are going to reiterate the concept and just a simple computations, but you know, and once you study that, you will be ready for the quiz. Okay, for the quiz, yes, we already had the quiz concept, the probability concept for the, when you took the exam, just a little bit, but still it helps. So on Thursday, I'm going to post a quiz on my math lab that will cover lecture 16. Okay, alright. So next time, lecture 17, see you again.